Hello everyone, I am Dr. Tanmoy Biswas. I welcome you all in my channel TanmoyChem. Today's topic of discussion is your MCQ and the question is in front of you. What is the major product of these reaction? I request everyone please pause the video, try by yourself, and whatever answer you get please write in the comment box along with few words as explanation. I believe you have tried, so let's start. By the way student, this question is a very conceptual question. So learn every bit of it. Now if you look at this molecule, it is actually phthalic anhydride. By the way, its name is PH THALIC, then anhydride. Now this PH is silent. Now this is phthalic anhydride. And if you look at this molecule, it's symmetrical. So from that point you can see. Now if you look at the above part, top part, so this carbon atom is attached with one oxygen here with a double bond and here with a single bond. We know carbon's electronegativity is nearly 2.44, oxygen's electronegativity is nearly 3.5 about. Now, so oxygen is significantly more electronegative and it is bonded covalently with carbon. So this bond will be polar. Because of higher electronegativity, this oxygen will pull some amount of extra electron density towards itself. So it will be represented by this delta negative. Since very small amount, that's why delta. Now consequently this carbon will have slight deficiency of charge that we represent by delta positive, means this carbon is slightly electron deficient. So obviously it likes some electron rich molecule. That's why this carbon center will be called as electrophilic carbon. Now since it is electron deficient, some electron rich molecule can attack here. Now if you look at here, this is methyl magnesium bromide. By the way, in methyl magnesium bromide or Grignard reagent, this carbon center is attached with magnesium. This magnesium atom is slightly more electropositive than carbon. Actually, you may consider this carbon is slightly more electronegative than magnesium. So this covalent bond is polar, actually nearly 34% polar. So it is actually delta negative. More electron densities of this carbon center has slightly extra electron compared to magnesium. So this is delta positive. Even this bromine also delta negative. Now you may ask me one question that, sir, okay, bromine is also delta negative, carbon is also delta negative. So why you are saying carbon will attack or carbon will act as nucleophile? Why not bromine? Remember, bromine is actually group 17 element. So they are halogen, means group 17 elements are called as halogen. So being a halogen, high electronegative atom, this negative charge on bromine is stabilized. So bromine is not that much reactive here. But if you look at carbon, it is neither very high electropositive nor very high electronegative. Its electronegativity value is actually in between. So consequently, this extra negative charge on this carbon atom is not at all that much stable. So that is the reason of its reactivity, and in this case this methyl group will act as the nucleophile, means it will attack the carbon center. Now this much we understand. Next point, here it is written that 2 equivalent. What this mean by that? Actually you may consider two molecules of Grignard reagent will react. By the way, ideally this information is not 100% accurate. For your academic learning point of view, if 2 equivalent written, it's fine. But from experimental point of view, it could be either 2.1 or 2.2 equivalent. What message? So you may consider that Grignard reagent is taken slightly extra amount. Why slightly extra? Remember, this Grignard reagent case, this carbon magnesium bond is very polar. So it is reactive. So it can react with moisture. Moisture means water. Okay. Because this water hydrogen is delta positive. So this delta positive hydrogen can react with the delta negative carbon in the Grignard reagent molecule. Now this much we understand. That's why it can react. Now actually this Grignard reagent reaction is generally done in ether solvent. Actually dry ether or dry THF, anything. Why? Because such that you can remove the moisture which can destroy the Grignard reagent. So this is point number one. Even the aerial environment or nitrogen environment that may have some amount of moisture. So in order to handle those impurities or moistures present, slightly extra Grignard reagent is taken. Okay, so in your question, either it is 2 equivalent given or 2.2 or 2.1 given, doesn't matter, meaning is same. and next step is workup. Okay, so I guess you have understood the background. Let's go to the main point. So methyl magnesium bromide, the first equivalent. So this is delta negative, so these will attack this delta positive carbon atom. Okay, by the way, this nucleophilic addition follows a principle named as Burji-Dunich trajectory. If you do not know about it, please visit. I have already made a dedicated lecture on it. So this nucleophilic attack will happen and this bond will be broken down because carbon atom cannot exceed its valency beyond 4. Done. So what is the product here? So you can expect this benzene ring will be as it is. By the way, student, I request everyone, please practice drawing. Otherwise, organic chemistry will be a difficult job for you. Okay, so this is methyl group. Now in order to neutral maintain this charge balance, so this MgBr part will remain as the counter cation. Okay, this is now this part, if you look at this carbon center is actually sp3 hybridized. So what it can do, it can undergo further reaction, means this pair can come here and it can leave. So what it will result, it will result actually a ketone. By the way, Grignard reagent, using Grignard reagent, preparation of ketone in one step is difficult. Okay, now this produces this one. Fine, done. Now why this reaction happened? First of all, this carbon oxygen double bond is more stable than carbon oxygen single bond, point number 1. Second part, this part is actually a good leaving group. Why it is a good leaving group? So if you look at here, this negative charge is delocalized with this double bond oxygen, so it has another resonance form, so that is the reason it is stabilized, so it leaves. Now here one question that okay, in my final molecule there are two reactive center. Yes, now one side is this carbonyl part I am talking, another side is actually this carboxylate part. Okay, so who is more electron rich? Now by the way, this part who is more reactive or more electron rich, I shall discuss after some time. Actually this carbonyl group is more reactive, means obviously like the previous logic, this carbon is attached to electronegative oxygen, so this is delta negative, delta positive, so this is again electrophilic. That's why the second equivalent of methyl magnesium bromide will attack here. Okay, following the Burji-Dunich trajectory principle. Now after this attack, what it will produce? Again sp3 hybridized carbon atom. By the way, both are methyl, so first methyl case one methyl and it's the second methyl, so this is O minus, and here this side is O minus. Okay, now what will happen in the next step? So this case right now no other reaction possible because this is carbon atom tetravalent. Now in the next step, upon workup, H3O plus. By the way, what is mean by H3O plus? Generally it means dilute acid at ambient condition, or you can say dilute hydrochloric acid, dilute sulfuric acid, like that, or sometime even aqueous ammonium chloride is used. Now why this is? If your product is tertiary alcohol, now let's look at here, this is OH attached to 2 methyl group, this carbon. Now here COOH. Now you may ask one question that why we must be so much careful that we need to take such kind of acidic salt. Actually it undergo hydrolysis, produce mild acidic medium, because if you look at this carbon atom, it is actually a tertiary carbon atom. Not only that, it is benzylic. We know both tertiary alcohol and benzylic alcohol are prone to protonation and water removal because the produced carbocation is very stable. So that's why very careful workup is needed. Now, so these will be our products. So one side carboxylic acid and other side tertiary alcohol attached with 2 methyl group. Now next question, let's go to this question, between ketone and carboxylate, who is more reactive? Now if you look at here, this carbon atom and here O minus. By the way, you can draw one canonical form of this. So okay, this oxygen will give its pair of electron, it will open up. So PHCO minus double bond O. And if you look at here, it's a double bond. By the way, you can say, sir, there could be another canonical form that okay, O minus plus. By the way, remember one of the rule of resonance, from neutral molecule, if you make a charge separated molecule, these molecules contribution in the overall canonical form or electronic distribution is less, because neutral molecule to charge separated species, there is some unstabilization associated. But it was previously a charge moiety. Again this happened, so no issue. Even if you look at such kind of molecules crystal structure, both of the carbon oxygen distances are same. They are neither double bond nor single bond, in between. So from that you can understand that this carbon is not at all electrophilic that much, but this carbon is significantly more electrophilic. So if it is more electrophilic, then nucleophile like this methyl magnesium bromide will preferentially react at the ketone carbonyl than this carboxylate carbon. Okay, so I guess this doubt is clear. So what is the answer here? After 2 equivalent treated with phthalic anhydride, here it could be carboxylic acid tertiary alcohol. So option D is the right answer. Now if you want to get this answer less than 30 seconds, how can you get it? For that purpose you need to follow a different strategy. So we understand ester carbonyl carbon is electrophilic and Grignard reagent nucleophilic, and 2 equivalent I told. So first case both are same, so any one attack will be there. So one side carboxylate, another side ketone, and these information you should remember student. This ketone or aldehyde is more electrophilic than carboxylate or ester, so they will be attacked by Grignard reagent preferentially. So actually same carbon will be attacked twice by this Grignard reagent, but where it is possible? Only these option. Now let's consider you do not know that much also. So how can you solve at this situation? Yes. Now Grignard reagent react with ester, produces ketone. Now if I say find this one, is it really an option? I don't think it's a logical option. It's not a logical option, so it's gone. Now you can say, sir, this one, but if you look at this is a one equivalent Grignard reagent type reaction, because one methyl group is introduced, one carbon. How this is possible? Because it is written 2 equivalent, so this is gone. Now if you look at here again, this double bond here it is, and by the way this is actually student, if you look at hemiacetal, remember hemiacetals are unstable in both acidic and alkaline medium, both case. So during workup it should not be there, so it should be broken down. So this is also gone. What is remaining? Option D. So there are many ways you can try using your logic, you can get the right answer, but one thing I always suggest, learn the concept completely, it will help you later. So this is the overall discussion. Thanks for watching. See you in my next video. Bye bye.